Okay, this screencast correlates to in our textbook, section 8.3, about scientific and standard notation. Standard notation just be how we normally see numbers written, how we've used them your whole life, most likely up to now. Scientific notation is used with either very large numbers or very small numbers usually, and writing them with just one number in front of a decimal place, and then times 10 to some sort of exponent. Sometimes the exponent's positive, that would correlate to having a very large number. And below here you'll see an exponent is negative, and we'll talk about it. Correlates to having a very small number, small decimal. So, you're going to take the number 6.2 and you're going to take it times 10 8 times. That's what exponents mean, just repeated multiplication for us. So, kind of show my work. You can do all these problems by hand. Your calculator can help you with it since there's really no variables, which reminds me, anywhere you see an X in this entire section in this screencast in your textbook, it's going to be a multiplication sign. This is the one section in algebra I'm kind of allowing that. We try and avoid showing multiplications with an X because that really confuses us with variables. Multiplying something by 10 just really moves the decimal place. It gets you a bigger number, moves the decimal place over once. I need to multiply it by 10 again and again, so that's 3 times. 4, 5, 6, 7, and 8. So basically I move my decimal place 8 spots to the right, giving myself a bigger number. I need to fill in all these spots with zeros, kind of as a placeholder. Okay, and if you think about what happened the first time, I moved it once, and I didn't add any zeros to it, and I had to move it another 7 times for my 8 total. So I should end up with 7 total zeros here. I need to have comma, comma. Okay, your number is going to be 620 million. There's thousands, millions. 620 million if you're going to read that number out loud. 6.2 times 10 to the 8th power. Very large number. And according to our directions, that's all we need to do. Just take the number, put it in standard notation without. Okay, the second example, very similar setup, but you notice the exponent on my 10 is a negative exponent. Since we just got done talking in our last section about what negative exponents mean, you know it means really you're going to take that number, reciprocate it, basically it moves to the bottom of this multiplication, and you got a 10 to the 6th power on the bottom. So you're going to take 5.34, divide it by 10 6 times. You're going to keep dividing by 10 over and over again, giving you a very small decimal. What that looks like as far as just moving decimal places, you divide something by 10, it makes it decimal place move 1 to the left. So I'm going to do that 6 times. I got 1, 2, 3, 4, 5, 6 movements, which give me 5 zeros in front of my 5. And I've talked about in the past, I never really care one way or the other if you put a 0 in front of a decimal place or not. So I usually don't, you've noticed that. So the final answer here is just going to be 0.000000534. We moved the decimal place 6 times to the left. This is what you're going to see happen. Positive exponents can make your number bigger, moving it to the right. Negative exponent can make your number smaller, taking that decimal to the left. Alright, that is taking numbers from scientific into standard. Let's reverse that process, giving you numbers that would be more convenient to have them written in scientific notation. So if you don't see a decimal anywhere in this first number, we want to think of the decimal being at the very end, the far right side. Scientific notation, your decimal needs to have only one number to the left of it. So here I have 3, 6, 9, 12, 13 numbers to the left of my decimal place. I only need one, so I want my decimal place to end up right here, just with one number on the left side. So how many times I got to move it? I got to move it 3, 6, 9, 12 times. One decimal place will be behind the 1. I need to keep the 0 to 5, but the rest of the zeros don't need to be written down. You never really need to write zeros behind any numbers on the right side of the decimal. Okay, so how I can change this number into scientific notation is say I'm going to take 1.025 times 10, then however many movements I made. I moved it 12 times. And you got to think positive or negative 12. It was originally a large number, so positive exponents will Can be kind of your key, your trigger to know that is a large number. So I want to keep it as a positive 12. This is a very small decimal. You see the decimal place, you want it to be right here with only one number to the left side of it. So this number has the same meaning as 9.002 times 10. And let's find out how many times I just moved it. Once, twice, 3, 4, 5, 6, 7, 8 times. I moved it 8 times. It was originally a small number, so I'm going to put a negative exponent on it. That way, if someone later is reading it, they can take it back out and know what we were dealing with originally. So, you took a number in standard form, put it in scientific notation. Okay, it's not going to be enough just in this section to do that. Actually have you do some operations. Multiply two numbers that are in scientific notation. See if you can come up with the answer. Once again, calculators will be able to handle these. I would think it would be worth you doing by hand and understanding the process. If you carefully read the directions, notice you're really going to have two answers here. Write it in scientific notation, write your answer in standard notation. Same number, just written twice. If you are using your calculators and making notes, make sure you use the parentheses on these problems, especially the division ones below, otherwise you're never going to get the right answer. Your calculator won't interpret what you're meaning correctly. So, a couple different approaches. I could turn this into standard form, this into standard form, and I could do a big long multiplication number here, or have my calculator help me. But, all that's really going to happen is going to be, you're going to take this 5 times this 3, and get 15. We talked about in this multiplication problem 2 sections ago, when we're multiplying, we have a base of 10 and a base of 10. We can just simply add their exponents. So it's going to be 15 times 10 to the 20th power. Of course, the number 15 times 10 to the 20th power is not in scientific notation. I want the decimal place to go from right here where it is to that spot. So I need to edit a little bit here. So it can be 1.5 times 10 to the, this is a bigger number than I'm originally showing it. So I'm going to add 1 to the exponent. I moved it one spot. It was a larger number. I turned into a small looking decimal. That's how I know the number got bigger by 1 opposed to getting smaller by 1. So here's half of my answer. It is this product, this multiplication I just did, showing my answer with scientific notation. Standard notation, I just need to move that decimal place over 21 times, basically resulting in a total of 20 zeros. Okay, double check that I did that right. There's 3. 18, 19, 20 zeros in the 21st spot would get me back to 1.5. Okay, I should have made a simpler problem if I knew I was going to have to be doing this work. So, 2 different answers on one problem. Now you're going to have it. Make sure you read the directions. Don't miss out on any silly points on an assignment or a test. Okay, if you want to double check that, you get the same results. Your calculator will be able to show you the scientific notation. Not too many calculator screens are going to be able to show you. They don't usually show more than 8 or 9 digits on the normal scientific calculator. Once again, even though these are decimals, you can handle it the same way. 5 times 8.1. 5 times the 8 is going to get you to 40, obviously. So if you're wanting to do it by hand, you're capable. I'll give you guys time to try it on the calculator if you're following along with me. So 5 times 8 gives you 40. 5 times a 0.1 gives you 0.5. So we were talking about 40.5. Not the best looking 4 I've ever made. 40.5, and once again, it's just one big multiplication. I can add my exponents. Add the negative 5 and the positive 21. So this makes a times 10 to the 16th power. Once again, that's a 40.5. I want the decimal place to be here. Just going to add 1 onto my exponent to get that accomplished. 4.05 times 10 to the 17th power. Here's half of your answer. Scientific notation, right here, you need to write standard notation, so for the sake of time, I'm not going to write it out, but that would be 405, and then another 15 zeros behind all that. double check, take your time on the homework problem, make sure you don't get it right. Or make sure you don't get it wrong by making a silly error. So you would have a big long number here. Okay, last problems. Same concept, taking two numbers that are in scientific notation, doing some operation. In this case, it's a division problem, set up as a fraction. So take it as kind of piece by piece. What is 7.2 divided by 9? Well, it would be an easy question if I asked you what 72 divided by 9 was. That would be 8, so in this case it's 0.8. Decimal place moved over once. So I divide the two numbers out front, I get 0.8. In a division, you really subtract exponents. So they both have a base of 10. I can take the 10 and the 6, subtract them, get myself a 4. So it's 0.8 to the 4th power. Once again, be careful. Don't think you're finished with the problem before you actually are. I want the decimal place to be to the right side of the 8. I want one number on the left side of my decimal. So change that into 8. You could write as 8.0 if you really wanted to, but that's where your decimal place is. Times 10. This is a smaller number. I turned it into a bigger looking number, 0.8 to an 8. So really, I need to take 1 off my exponent. And if you type this incorrectly into a calculator, it would have to look like this. Parentheses in those spots in between your division. Otherwise, your calculator's not going to know what you mean. You're going to get the wrong exponents. Either way too big or way too small of a number, depending on what the problem's set up as. So 8 times 10 to the 3rd power is really just the number. I moved that 3 times. 1, 2, 3. That's just the number 8,000. Scientific or standard notation. Not a very large number relative to the ones we were working up above. Okay, I had to go in and edit this last problem. I got a little carried away with my decimals and made a much harder problem than we're ever going to have to face. I want these numbers to work out fairly well. So 11.7 divided by 2.25, trust your calculator or work it out by hands. You're going to end up with 5.2 by dividing these two numbers. We're going to write it in scientific notation first. Time 10 to the, if I find a difference between these numbers, it is negative 7. Basically 5 minus 12, negative 7. So we're dividing by a much larger number than we had on top, so we know we're going to end up with a small decimal as an answer. There's already one number to the left side of the decimal, so scientific notation is taken care of. If I want to write that same number, I can move it over 7 times. So right here is where my decimal place is. Move it over 7 times. There's 1, 2, 3, 4, 5, 6, 7. You're going to end up with 6 decimal places in front of your 5.2, if done correctly. Pretty small decimal, but that's what you would expect with a smaller number being divided by a bigger number. 2.25 times 10 to the 12 is the larger of those two numbers. So remember, if you're trying to do the entire thing with your calculator, you're not going to get it right unless you do parentheses around the top and a separate set of parentheses around the bottom. Okay, that's all we got for 8.3, and we're going to do a quick test after this section over our first 3 sections of Chapter 8.